notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, all 33 of those videos have been published on YouTube already in their entirety. Section 2, all 12 of those videos have been published on YouTube already in their entirety. Section 3, all 6 of these videos have been published on YouTube in their entirety already. So those are 51 videos from section 1, 2, and 3, all published on YouTube in their entirety. Please make good use of them. We are now at section 4. This is the 14th of 17 videos, and I am behind schedule. January 2025, behind schedule there as well, statistics. And then by February 2025, hopefully, algebra. March 2025, relations, functions, and graphs. By April 2025, geometry and trigonometry. And still hoping to keep this schedule, May 2025, vectors and matrices. Please note this disclaimer here. The schedule is just a projection which may or may not be fulfilled. Please don't interpret it as a contract. As I said, section 1, I have divided in 33 videos. These 33 videos that you see on the left here. This section forms the foundation on which the rest of the syllabus is based. So please make sure you look at these 33 videos and know them well from section 1 in order to do the rest of the syllabus reasonably well. A reminder that you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. As I said, all 12 videos from section 2 have been published. All 6 videos from section 3 have been published in their entirety on YouTube. We are now at section 4 at this point here. So far, these 3 have been published in their entirety on YouTube, and these others have only been partially published, including this one here, video 13. We are now here, objective 12, speed, distance, and time, video 14, and this one will be published in its entirety on YouTube. So objective 4.12, average speed, distance, and time. Before we go on, recall I said in the introductory video that you will need to get a good math textbook or a set of 2 to get more practice questions. CSEC recommends the following shown at right here. These. From that list, I would recommend a very good 2-volume set that is quite adequate for the current CSEC math exam. And this is a picture of volume 1, Mathematics, a Complete Course with CSEC questions, with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer down here, I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you have a question that you need explained, You can ask AI assistant either by text or voice, and most likely that will be explained to you. This is the URL for the website. On the next page, I will show you a picture of the home page of that website, RSC. So as I said, that is the URL. I will include that URL in the description of this video below. This is the home page. Of course, you have to register first. And once you do that, subsequently, you would sign in. As I said, it's free of cost. We have completed all 4 objectives on this page from section 4. And then on the next page, all 5 of these objectives that you see here. That would make it a total of 9. And then we are here on the last page. We have completed objective 10 and objective 11. We are now here. Objective 12, solve problems involving relations among time, distance, and speed. We have a little explanatory note here, which deals with average speed. And when we get to objective 15, that would be the end of section 4 on measurement. Now, this is the first part of the formulae and tables that you will be given in the exam. This is the top part. Notice that there is no formula for average speed, but that is understandable since it is very, very easy. And this is the below part of that same formula sheet. Again, there is no formula for average speed. But as I said, it is extremely easy, somewhat similar to area of a rectangle. So you don't need that on this formula sheet. So 4.12, solve problems involving time, distance, speed, and involved in that is average speed. Average speed is total distance over total time. Now, you may have seen a diagram like this with D, S, and T. Simply means that S is equal to D over T. As you could see here, this line here is over. And if you come over here, T is equal to D over S. And of course, up here, because these two are side by side, D is equal to S times T. Now, that may be a way to help you remember this, but as I said, it is extremely simple. Now, if you are taking also physics, note that this triangle has slightly different symbols. And that is because both D and S represent distance in physics. So up here, instead of having D alone, you would have both D and S there. T is still here. So what do we have over here? For average speed, we have bar V, average velocity or average speed. So average speed is now equal to that over this, D or S over T. And then, of course, time is equal to D or S over V, like that. And finally, D or S up there is equal to bar V times T, V times T. Well, that is for physics. So you may not have seen something like this in a physics textbook, but you may see something like this. Average velocity or speed is equal to delta S, meaning change in distance, over delta T, change in time. So now let's get back to this one here that you are more likely to see in a math textbook. Introduction. If you walk from home to the local village shop and it took you 12 minutes to cover that distance of 530 meters, what was your average speed? Now, some parts you may have walked faster, some parts slower. But what was your average speed? Well, remember we have this. We want to find speed, so we'll have to divide d by t. So average speed is equal to distance divided by time. Average speed is equal to distance divided by time. The distance is 530 meters. Time is 12 minutes. So average speed will be 530 meters divided by 12 minutes. And you get an average speed of 44.16666 meters per minute, which actually work out to be 0.736 meter per second. Essentially, it's a little over 44 meters per minute, or a little under 3/4 meters per second. So that's your average speed if you go in meters per minute or meters per second. This down here is a little more understandable. So now, example 1. An Olympic athlete ran a distance of 100 meters in a total time of 10 seconds. Notice one significant figure, one significant figure. Calculate his average speed. Well, we know speed is equal to distance divided by time. We divide 100 meters by 10 seconds and we get 10 meters per second. This has the correct number of significant figure, 1. But to make sure that everybody understands that you are rounding off here, you take half of that 10 position, which is 5, so you get 10 plus or minus 5 meters per second. Now, if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. So we continue with example 2. A student lives uphill 2.5 kilometers from school. She takes 25 minutes to walk to school and 35 minutes to walk back home. Calculate her average speed in meters per second for the whole trip. So the total is 2.5 kilometers one way. Two-way will be 5.0 kilometers or 5,000 meters. Total time is 25 minutes walking down to school and 35 minutes walking back up home, which would be 60 minutes, which is 3,600 seconds. So average speed will be total distance over total time. We have the total distance here in meters. We have the total time in seconds. Divide those two and we get 1.388 meters per second. You know that is too precise. It has too many significant figures. So let's see, we have 2 significant figures there, 2 significant figures there, 2 significant figures here. Our answer can only have 2 significant figures, so we need to round off where that 3 is. So we get 1.4 plus or minus 0.05 meters per second. Example 3. A plane took 2 hours and 12 minutes to fly 1,500 kilometers from airport X to airport Y, and then took an additional 1 hour 45 minutes to fly 1,125 kilometers from Y to Z. Calculate its average speed from X to Z in, first of all, kilometers per hour, and secondly, meters per second. All right, so total distance will be that 1,500 kilometers plus 1,125 kilometers, which gives us 2,625 kilometers. At this point, you have 2 significant figures because you're supposed to round off here. 2,625,000 meters. Total time, 2 hours 12 minutes plus 1 hour 45 minutes. That will give you 3 hours and 57 minutes, or 3.75 hours. 3 significant figures. 14,220 seconds. Average speed would be total distance over total time. That's the total distance, that's the total time. We get this answer, 664.577 kilometers per hour, which obviously is too precise. We have too many significant figures. We have to round off the two significant figures, which is here, and that would give us 660 plus or minus 5 kilometers per hour. Now that's kilometers per hour. We can work this out in meters per second because we know the distance in meters here. We know the time in seconds here. And we get 184.599 meters per second. Obviously, that has too many significant figures. We round off to two significant figures and we get 180 plus or minus 5 meters per second. Now, we could have carried kilometers per hour to meters per second directly without going through this second step here. So we multiply that by 1,000 to carry kilometers per meter. And once we get that number, we divide by 3,600 the number of seconds in an hour, and we get this, which is exactly the answer we had up there. If we round it off, in both cases for meters per second, we get 180 plus or minus 5 meters per second. So that and that are the same. Example 4, on her way back to boarding school after summer break, Akan has to travel first by taxi from her home to train station Q, which is a distance of 12 kilometers and it takes 25 minutes by taxi. Then she has to travel by train from Q to R, which is a distance of 876 kilometers, and that takes 14 hours and 34 minutes, inclusive of the waiting time at train station Q. And finally, she has to travel by bus from R to school, which is a distance of 35 kilometers, and that takes 45 minutes, inclusive of calculate her average speed in kilometers per hour from the time she left home when the taxi picked her up there to the time she arrives at school. So total distance is 12 kilometers plus 876 kilometers plus 35 kilometers, and that gives you 923 kilometers. This is 3 significant figures because we are adding now, not multiplying. Total time, 25 minutes plus 874 minutes, that is the 14 hours and 34 minutes, plus 45 minutes, 944 minutes, 3 significant figures, or 15.733 hours. Average speed will be total distance divided by total time. As a total distance, as a total time, we want our average speed in kilometers per hour. Divide those two, and we get 58.67 kilometers per hour. Maybe if you leave it like that, CSEC will accept it. But rightfully, we are allowed 3 significant figures only. So we need to round off where that 6 is. And so our answer will be 58.7 plus or minus 0.05 kilometers per hour. Example 5, the average speed of an athlete for the 400-meter race was 49.5 meters per second. What was his time for this race? All right, now this time we are not asked to find speed, we are asked to find time. No problem, we are given distance and we are given the speed. So time will be distance over speed. So average speed is distance over time. Time will be distance divided by speed. We put in those numbers here. The distance is 400.0. That's 4 significant figures. The speed is 49.5 meters per second. 3 significant figures. Now we are dividing. So our answer cannot have more significant figure than the factor with the least number of significant figures, which is, we work that out and we get 8.080808 and so on. Three significant figures, 1, 2, 3. Our answer is 8.08 plus or minus 0.005. Remember, those two zeros are for these two digits on the right of the decimal point. Example 6. Example 6. A plane flies from airport P to airport S at an average speed of 790 kilometers per hour. If it takes 3 hours and 45 minutes to do that, what is the distance that the plane traveled from P to S? So now we want to find distance. We know the average speed and we know the time. So obviously distance will be equal to speed multiplied by time. So speed is distance divided by time. Distance will be speed multiplied by time. So the time is 3.75 hours. That is, this 45 minutes here is 3/4 hour. And the average speed is 790 kilometers per hour. Multiply those two and we get 2,962.5 kilometers. Obviously, we have too many significant figures there. Our answer is too precise. So we will have to round off to 2 significant figures, which is where that 9 is. And since this is 6, we will have to increase that 9 by 1 and take that 1 over to the 2 here. So now we get 3,000. But since that may be misinterpreted as rounding off at the 3, we add half of the position at which we have rounded off, which is the hundredths position. So half of 100 is 50. So that way it is clearly understood where the uncertain digit is and where we rounded off. Better still, if you could write it like this, you can see the 2 significant figures there, meaning we rounded off here. This cannot be misinterpreted. Example 7, a journey of 78 kilometers from his office to his home in the afternoon rush hour normally takes Mr. Thomas 2 hours and 15 minutes on average. This afternoon, along his way home, he has to stop at a supermarket 25 kilometers from his office for 15 minutes. Now, if he travels the average speed to the supermarket, what will his average speed need to be from the supermarket to his home if he intends to reach home at his usual time? In other words, he would have to travel a little faster to make up for this 15 minutes loss at the supermarket. So first of all, we will find his normal average speed if he didn't stop. And that will be 34.667 kilometers per hour. A little less than 35 kilometers per hour. Now the time to the supermarket is 25 kilometers divided by that speed to the supermarket, which is 43.27 minutes. Time elapsed at leaving the supermarket or on leaving the supermarket is that time that he traveled to the supermarket plus the 50 minutes he spent at the supermarket, which is 58.27 minutes. Now the time remaining to reach home, remember he normally takes 2 hours and 15 minutes. So from the 2 hours and 15 minutes, we will subtract the time that he traveled to the supermarket plus the time he spent at the supermarket, and that leaves him a time of 1.279 hours. The remaining distance is 78 kilometers minus 25 kilometers, which is 53 kilometers. So we will divide this 53 kilometers that he has to cover in that time there. Therefore, average speed from supermarket So home would be 53 kilometers divided by 1.279 hours, and that gives an answer of 41.4386 kilometers per hour. Of course, we have too many significant figures here. We have to round off to two significant figures, which is here, where that 1 is, which is the 1's position. And so we get 41 plus or minus 0.5 kilometers per hour. So notice his normal speed would have been 34.5 kilometers per hour, but because of the time spent at the supermarket, he had to travel a little faster, 41 kilometers per hour, to make up for the time lost at the supermarket. So he could arrive at home at his normal time. So now, as it relates to this matter of average speed, let's revisit example 1. That was example 1. And we came up with this answer. Now, if we are not careful, we can misinterpret this to mean that for every 1 second, the athlete runs 10 meters, because it says 10 meters per second. But that's an average. And we may get an idea something like this. So every minute, 10 meters, 2 minutes, 20 meters, another 10, and so on. Something like that. Actually, this is not what happens. So that there is not actually what happens. It's more something like this. He has to pick up some speed, or she, and maintain the speed until the end. That's somewhat ideal. But on average, it is still 10 meters per second. An average. 10 seconds, 100 meters. It is still on average. And even this may not actually be correct. This certainly is wrong. This is not what happens. This, I think, is more or less what happens. Speed up, speed up, speed up, slow down a little, keep that space, slow down a little, and the race ends here. So you could see every second the speed actually changes somewhat. And in reality, this is what most likely happened. But when you say the average speed is 10 meters per second, it may give a wrong idea that every second the athlete ran 10 meters. So we just completed this objective. Solve problems involving time, distance, and speed. And that brings us to the end of video 14 based on objective 12 from section 4.